So let's set the scene. Imagine you need to know the temperature of a fluid, but it's inside this big metal pipe, and that pipe is covered in, say, 2.5 inches of insulation.
Right. And you can't just cut into the pipe.
Exactly, or strip away all that cladding. That's a huge job, maybe even a shutdown. It's a real pain point in a lot of industrial settings.
It's that classic trade-off, right? You want the data, but you can't compromise the integrity of the system to get it. Usually you have to sacrifice something.
Unless you have the right tool. And today, we're doing a deep dive into what looks like a really elegant solution. It's the NTI E-STSP-SL-7 strap-on pipe temperature sensor. Our mission is to unpack how this thing, with its spring-loaded design, actually solves that whole intrusion problem.
And it's important to note this is for a very specific setup. We're talking insulated metal pipes between 5 and 14 inches in diameter.
Okay, so with normal strap-on sensors, the big issue is always contact.
Right.
If there's even a tiny air gap between the sensor and the type.
Your data is useless.
Yeah.
You end up measuring the temperature of the air, not the pipe.
So how does this NTI sensor get around that? What's the spring-loaded part all about?
That's really the clever bit. It uses this little copper contact point, and it's on a spring mechanism that physically presses through the insulation.
Oh, interesting.
Yeah, and it can handle insulation anywhere from 1/2 inch up to 2.5 inches thick.
So you're saying the spring is what guarantees you have constant positive pressure on the pipe wall.
Exactly. It maintains this firm, consistent contact. You just have to core out a tiny little hole in the insulation for the probe. So instead of major surgery, it's more like a tiny keyhole.
And that copper contact gives you a direct thermal path.
A perfect path. It effectively bypasses all that ambient noise from the air gap.
Okay, but is it actually responsive? You'd think a surface reading would have some serious thermal lag compared to, an immersion probe.
You would, but the specs on this are surprisingly tight. The accuracy is within plus or minus 1 degree Fahrenheit, and the response time is less than a minute for a 2-degree change.
That's snappy enough for almost any process control loop.
Yeah.
But here's the kicker for me. This thing is going to be buried under insulation, probably somewhere that's a real pain to get to.
You do not want to be going back to replace it.
Never. So what about longevity?
This is the part that sounds like a typo. The mean time between failure, the MTBF, is rated at 3,540,911 hours.
I actually ran the math on that before we started. That is over 400 years.
400 years. I mean, it's just a statistical abstraction at that point, but what it means is this sensor will outlast the facility it's monitoring.
It's a true install and forget component.
Completely. The datasheet even says recalibration isn't needed after the initial setup.
Okay, so let's talk about getting that data out. It plugs into the NTI ENVIROMUX system. It uses a digital output signal, which I assume is way better than analog over long distances.
Oh, absolutely. That digital signal gives you huge resistance to noise. Think about all the interference on a factory floor-heavy machinery, variable frequency drives.
All that EMI.
Right. An analog signal would get degraded, but this digital one stays clean.
And you're not stuck having to place your monitor right next to the pipe.
Not at all. It comes with a 7-foot CAT5e cable, but you can run standard CATx cable for up to 1,000 feet.
1,000 feet.
And if that's not enough, you can add one of their fiber converters, an EFSC, and then you're looking at a range of about 1.2 miles.
So you could monitor a remote steam line on the far side of a plant from one central control room. No problem.
While keeping the hardware safe. The enclosure is NEMA 1, IP20 rated. It's designed for that kind of industrial environment.
It really does seem like the complete package then. You're getting high-precision data without having to perform major surgery on your infrastructure.
It creates this invisible layer of monitoring and safety. These are the silent sentinels that are, making sure systems don't overheat or freeze up, and we never even see them.
It makes you wonder, if we can solve this problem so elegantly, what other blind spots are out there in our infrastructure that we're ignoring, just because we assume they're too difficult or too expensive to measure?
That's the question every facility manager should be asking themselves.
Something to think about. Well, thanks for listening to this deep dive.